Okay, here's some example problems forming images with mirrors. So here's our first problem. Imagine you have a mirror with a focal length of 15 centimeters. You place a 0.1 centimeter tall wasabi bean 20 centimeters from it. Where will the image form? How big will the image be? Will it be inverted or upright? And will the image be virtual or real? So basically, we are given f is 15 centimeters, p is 20 centimeters, and we want to know q. If q is positive, that means that the image will be on the same side of the mirror as the object. If it's negative, it's on the opposite side. If q is negative, let's see, the magnification is minus q over p. So if q is negative, that means the image will be upright. If it's positive, it will be inverted. If q is positive, the image is real. If q is negative, it's inverted. All right, so basically we just need to know q to make this work. And our basic equation is 1 over f is 1 over p plus 1 over q. All right, so 1 over q then is 1 over f minus 1 over p, right? Just take the 1 over p to the other side. That means that q is equal to 1 over f minus 1 over p, 1 over that, right? Raised to the negative 1 power. All right, so just pull up Python, and p is equal to 15 centimeters, right? Yes. Yeah. And, sorry, no, f is equal to 15 centimeters. P is equal to 20. Did I do that right? Let's go up a slide. 15, focal length is 15, P is 20. Alright, and so Q is equal to 1 over F minus 1 over P, all raised to the negative 1 power. So Q is 60 centimeters. Alright, there we go. So it is a real image because Q is positive. Because Q is positive, it's on the same side of the mirror as the object. All right. Also, because Q is positive, we know that the image will be inverted. And how big will the image be? H prime is equal to H times the magnification. But the magnification is just minus Q over P. So the image will be how tall? 0.1 times negative Q divided by P. So 0.3 centimeters, negative 0.3 centimeters. So the image will be 0.3 centimeters tall and it will be inverted. There it is. Okay, now how do we do this by drawing pictures? Alright, so I've got my mirror. The furthest thing from it is going to be my 60 centimeters. The focal length is 15, the object's 20, the radius of curvature is 30. So I need 60 centimeters to work with. So let's take my grid right here. I've got 11 of these. So maybe I'll let 10 centimeters be one of these. So here's going to be, let's put my mirror right here. And I apologize, it's really hard to draw straight on here. It's going to be a converging mirror. So hopefully I get a decent answer. When you do this on the homework, you should use rulers. I can't really put a ruler on my tablet and have it work out. And PowerPoint doesn't let you do sketching with straight lines. And putting straight lines down and moving them just takes forever. So we're going to do the best we can. Alright, so the focal length is 10, 15. So there is going to be my focal point right there for my mirror. Alright, my object is going to be 20 centimeters away, so 10, 20. And it's 0.1 high, and it's going to end up being negative 0.3 high at the end, right? So let's use one box to represent 0.1 centimeters. So the scale in this direction, this is 10 centimeters. And in this direction, this is going to be 0.1 centimeters. All right? Okay, there's my object, there's my focal point. The radius of curvature for my mirror. If my focal point is 15 centimeters, my center of curvature is going to be 30 centimeters away. All right? So there's my center of curvature. All right, the first line I draw is the one that goes to the center. It's going to come back, and it's going to go boom through there, like that. Pretty good without a ruler, hey? If I say so myself. Alright, the ray which is traveling parallel to the optical axis will reflect and go to the focus. Alright, so it's going to go there, and then here, and then here, and so forth. Alright, a ray which goes to the focus, down here, it's going to come out parallel. I didn't draw that very well. If you draw this with a ruler, you'll get something like that, right? And then the ray which goes to the center of curvature is going to come straight back. Boom. right there. Sorry, horrible lines. Hopefully you get the idea from my example, but that's where the image forms. I hope this solidifies in your mind that you really need to use rulers and draw carefully if you're going to get the right answer drawing when you do this. All right, graph paper's nice, rulers also essential. All right, okay, so there's where my image forms. By drawing rays, I drew how many rays? I drew 1, I drew 2, I drew 3, I drew 4. So with these 4 rays, they all, if I draw them carefully, they'll converge here. I see that my object is 10, 20, 30, 40, 50, 60 centimeters away from the mirror. On this side, it's a real image and it's inverted, and I started off with an object that's 0.1 centimeters high, and my image ended up being 0.3 centimeters high and inverted. Okay, now, converging mirror. Now let's imagine I have the same mirror, but I'm going to place my wasabi bean only 5 centimeters from it. Where will the image form? How big will it be? And so forth. So we're going to do the same, it's going to be the same problem, right? We're going to end up with Q is equal to 1 over F minus 1 over P to the negative 1. Only now we've changed what P is. P is now going to be only 5 centimeters. So let's go to Python. Let's set P to 5 centimeters. The focal length is still 15 centimeters. So Q is going to be 1 over F minus 1 over P raised to the negative 1 power. And now Q is minus 7.5. All right. So what does that tell us? First of all, Q is negative. That means the image will be on the opposite side of the mirror from the object, the opposite side from where our eye is, on the side that the light doesn't go to. All right? It will be 7.5 centimeters from the mirror. The negative sign also tells us it will be a virtual image, not a real image. All right? Will it be upright or inverted? Remember, magnification is minus Q over P. So if I have a negative Q, I get a positive magnification. It will be upright. All right? So there's the answer to the problem. It will be 7.5 centimeters into the mirror. The image will be upright and it will be virtual. How big will the image be? All right, well, we find that. We take 0.1 times negative Q divided by P. It will be 1.5. So H prime will be 0.15. All right, now let's see if we can get those same answers by drawing. Okay, so now our object's 5 centimeters away, focal length is 15, radius of curvature is 30, so we need 30 centimeters on one side and about 10 on the other, so we need about 40 centimeters of space. So this time I'm going to let 2 of these be 10 centimeters, alright? So so here's 10, 20, 30. If I put my mirror right here, alright, and then 2 of these big boxes is 10 centimeters. So 10, 20, 30. There's the center of curvature. And 10, 15. There's my focal point. And my object will be 5 centimeters away. All right, now how tall do I want to make my object? It is 0.1 centimeters. And then it's going to end up being just a little bit bigger than that, 0.15, just 50% bigger. So let's let 0.1 be 2 of these right here. All right? So this distance right here from 2 of these is 0.1 centimeters, and this distance right here, that we've set is going to be 5 centimeters in the x-axis. All right? So now I'm going to draw my lines. All right? My first line is going to go right to the center. Boom. And that's going to reflect down like this, and like that, and so forth. Alright, and then I'm going to have a line which travels parallel to the optical axis. This is my optical axis down here. That line is going to go to the focus. So it's going to go over 3 and down 2. So like that, over 3, down 2. There we go. Alright, now I don't have a ray of light. If I shoot a ray of light through the focus, it doesn't hit the mirror. So for this one, I'm going to say a ray of light that is coming from the focus here, alright, so a ray of light going in that direction is going to come out parallel to the optical axis. And a ray of light, 1, 2, 3, 4, 5, and 2. So a ray of light coming up this way is going to come straight back, like that. So then what we do is we extend these lines out here. We say, look, I've got these rays that are diverging. If I look at this with my eye, it's going to look like these rays are coming from a point over here. That ray looks like it's coming from over here. This ray, let's see, 1, 2, 3, and up 2. So if I go up 1, that's going to take me up 1.5. So this one's going to come up right there. If I were doing this with a ruler, this would be a lot easier. This one goes up 2 for every one it goes over, so like that, and then like that, something like that. And then we've got this one that's coming straight back right there. It looks like my image is going to be right about here. If I were using a ruler, this would be a lot more accurate. Okay, so how far away was my image? So we said this is 5 centimeters. No, it looks like a little bit more than, let's see, so this is 5. So that means each one of these little ones is 0.5. So 5, 6, 7, 7 and a little more than 7.5. We said the answer should be 7.5, and I got something which is really close to 7.5 centimeters on the opposite side. Alright, so if I draw this with a ruler, you can imagine I could get this pretty accurately. Drawing freehand, not so well. Make sure you use a ruler. How tall is it? Oh, I didn't draw my lines very well, but it looks like, whoops, come on, come back. I didn't draw my line all the way to my optical axis. I should have penned in my optical axis so I remembered where it was. If I do that accurately, then I see this is really my image line, and it's 3 of these, whereas this was only 1 of them, so it looks like my height of my image is about 0.15 centimeters, as it should be. So I got something pretty close. If I drew this with a ruler, it would probably be really close. But there are the basic lines that I drew. My first one was bounce off the mirror at the center, law of reflection. Next one was a line that was parallel to the optical axis, went to the focus. One that came as if it were coming from the focus comes out parallel. One that came as if it was coming from the center of curvature continued straight back. And then I extended these lines in to find where it looked like these rays were coming from, to find the position of my virtual image. Okay, one more type. That should be I, right? I forget. Anyway, you'll forgive me for my typos. Imagine that you have a mirror with a focal length of -20 centimeters. So now we have a diverging mirror with a negative focal length. You place a 0.1 centimeter tall wasabi bean 10 centimeters from it. Well, where will the image form? How big will the image be? Will it be inverted or upright, and will the image be real or virtual? Okay, sort of same thing. We're trying to find Q. And once again, Q is going to be 1 over F minus 1 over P to the -1 power. Only this time, F is going to be -20, and, come on, P is going to be 10. So Q is equal to 1 over F minus 1 divided by P, all raised to the -1 power, and that gives me -6.66666, whatever. Alright, so this is going to be -6.67 centimeters to 3 significant digits. Alright? How high will what will the height of the image be? Well, the object is 0.1 centimeters. We multiply that by the magnification, which is minus Q divided by P, and we get 0.0667. 0.0667 centimeters. So there we go. Q is negative, therefore it's a virtual image. H prime is positive, therefore it will be an upright image. Alright? And the image is going to form on the opposite side of the mirror from your eye, which is the opposite side from the object. Alright, let's see if we can get that by drawing pictures. So again, I've got a mirror that's 10 centimeter, let's see, 20 centimeter focal length, which means if I want to draw the radius of curvature, I need 40 centimeters. My image is going to be 6, so my 40 already covers that. But then I need 10 centimeters on the other side to draw the actual object. So it looks like you need about 50 centimeters. So I'm going to use, I'm going to put my center of curvature right here. And I'm going to let each of these be 5 centimeters. So my mirror has a focal length of -20. So it's negative. I'm going to put my center of curvature is on this side now. It's a diverging mirror, a convex mirror. So my center of curvature and my focal point's over here. And we said the focal length is negative 20, so this is 40. So here's 5, 10, 15, 20, 25, 30, 35, 40. So let's put our mirror right here. Alright, our focal length is going to be 20, so 5, 10, 15, 20. So my focal point's on the other side of the mirror now because it's a negative focal length. Alright, and then the other thing I need is my object, which is 10 centimeters from it, 0.1 tall. So 10 is 510 right here, and we'll let two of these be 0.1. Actually, yeah. So there's my object right there. Okay, so what are my 4 lines? One of my lines is the one that hits at the center. It reflects using the law of reflection like that. Alright? A line which is going parallel to the optical axis, and let's write in my optical axis so I don't forget where it is again. Alright? A line which is parallel to the optical axis, since this is a diverging mirror, it doesn't go through the focus, it bounces away as if it came from the focus. 1, 2, 3, 4, 1, 2. So it's going to come up, bounce up something like this, as if it were coming from the focus, right? There's that one. Then a ray of light which is going as if it was going towards the focus. Alright, so it's going towards the focus, and the focus is 1, 2, 3, 4, 6, and 2. So I'm going to come down like this, as if I were going to the focus. It's going to come away. It's going to come away from here. It's going to come out parallel, right? Now this would be much better if I were doing this with a ruler. And then my last line is one that goes towards the center of curvature. It's going to come straight back, right? And boy, I did not do a great job here drawing my line straight. But let's just extend these lines, right? We're over here, we see these rays coming away, and let's look at these two right here. This is an easy one to draw. And it looks like we're going to be right about here is our image, right? And I can extend these other ones. This one kind of crosses in there. This one I drew horribly. Okay, here we go. This one, no, it's not so bad. This one comes down, it comes out like this, so it looks like it's coming from over here. Looks like all of my lines are crossing right about there, and there's 5, 6, 6 and like a half. That looks like about 6 and a half. I should have gotten 6.67, so pretty good. The height looks like it's a little bit more than half of 0.1 centimeters, so like about 0.06-ish. I should have gotten 0.0667, so not horrible. Could have done much better if I'd done this with rulers. But once again, the lines I drew were reflection off of the center. Line which is going in parallel bends as if it was going away from, it bends away as if it was coming away from the focus. A line which is shooting towards the focus comes out and is parallel to the optical axis. And a line going towards the center of curvature bounces and comes straight back. These lines did not come to a focus, so I project them back to find where it looks like they're coming from. And there's my virtual image right there.